So this was one of the questions that were given in the test. Discuss the formation characteristic and types of sedimentary rock. What are its importance? So in these questions, as we discussed, first you have to write regarding introduction. So what you will write regarding introduction? So you can write sedimentary rocks. Sedimentary rocks are formed due to weathering, comma, erosion, comma, compaction, comma, cementation of material derived from igneous rocks. Okay, so that can be one of the introduction that you can find, you can write regarding sedimentary rock. These are the rocks that are formed due to weathering, erosion, compaction, cementation of material derived from igneous rocks, and these rocks are formed at the surface or near to the surface. So this can be your introductions for looking at the question. That sedimentary rocks formed due to weathering, erosion, compaction, cementation of material derived from igneous rock. These rocks are formed either at the surface or near to the surface. Right? Now, as we discussed, what are the keywords over here? So you have to explain the formation, you have to explain the characteristic, you have to explain the types, and what is the importance. So your answer should be written in these areas, okay, in these forms. Okay, so answer should be written in these areas. Now, the first part that you have to explain is formation of sedimentary rocks. Formation of sedimentary rocks. So in formation of sedimentary rocks, you have to write about processes, how sedimentary rocks are going to be formed. So first process is what? Weathering. So weathering of igneous rock needs to take place, and that is the first process. Second, what you have to write regarding erosion and transportation. The second you have to write regarding erosion and transportation. That when the rocks are eroded, let's say igneous rocks are formed over here. From here, the material has to be eroded and transported to different locations. So the second process that you have to write is erosion and transportation part. The third is deposition. The third step will come is deposition. So when the rocks are eroded, they are deposited over here. These rocks are deposited over here. Here. So the third step is deposition that you have to explain. The fourth step is compaction. So these deposited rock will then compact to form a single rock, that is called as deposited material will then compact to form a single rock, which is referred as a sedimentary rock. Compaction. And fifth is cementation. So these are the terms you have to use to explain formation of sedimentary rocks. Should be your introduction. Sedimentary rocks are formed due to weathering, erosion, compaction, sedimentation of material derived from igneous rock. These are formed either at the surface or near to the surface. Then in formation of sedimentary rocks, you explain one line regarding weathering, erosion, transportation, deposition, compaction, cementation. These processes you need to maintain. You need to explain. Yeah, but okay, here you are explaining these part. Okay, you are explaining this term. What is weathering? What is erosion? You are explaining this term. You have just given introduction that how it is formed, and then okay, you are explaining those terms. What is weathering? What is erosion? So you have to explain what is weathering. Weathering is nothing but okay, the breakdown of what? Breakdown. So you have to write the heading as weathering, and then you have to explain. Write the okay erosion. Explain one line. Okay, not more than one line. You don't have, because it is asking lot of things, characteristic also, types also, so it is asking lot of things. So just explain one line, what is weathering, what is erosion, what is deposition, compaction, cementation. You have to explain one line regarding this. Fine. Then after formation, what is being asked? Characteristic. So the next part that you have to explain is a characteristic. Characteristic of sedimentary rocks. So characteristic of sedimentary rock. The first thing that you can see is it is a layered or stratified rock. It is which type of rock? Layered or stratified rock, formed by layer deposition. So we have to talk about it is a layered or stratified rock. Then second, it is fossiliferous, contain fossils. So explain about that it contains fossil, it is having the fossiliferous nature. The third thing that you have to explain is what? The size, and texture. So generally it can be of coarse size also, of small size also. Like we discussed, coarse size means what? Bigger. Like you have which type of rock? Arenaceous, and smaller, argillaceous. So size of the rocks can be either bigger or smaller. The material that is present in the rocks can be bigger or smaller. So you can have layered or stratified rock. You can have what fossils. You can have the structure, size and structure you need to explain. Grain size you need to explain. So that part you have to explain. Clear? And you can also mention about it is composed of what? It is composed of mineral resources. It is composed of mineral resources because igneous rock contain mineral. So when it is eroded and formed from the igneous rock, it is going to contain mineral resources. Okay, what are the common mineral resources we have discussed?
Coal and petroleum.
That is fossils. Okay, energy resource. Okay, what are the common resources? If you remember, we discussed much of our earth crust is made up of which type of mineral? Feldspar and quartz. Okay, so much of our minerals is made up of what? Feldspar and quartz. Remember, quartz is SiO2, feldspar we discussed silicates. Okay, that is present. So you can talk about characteristic of sedimentary rocks and you can mention these particular points. Characteristic of sedimentary rocks. Then you have to explain what types of sedimentary rocks. Then you have to explain types of sedimentary rocks. So in the types, you just make the diagram. We discussed mechanically formed, chemically formed, organically formed. Mechanically formed is divided in arenaceous and argillaceous. So make the diagram arenaceous, argillaceous. Chemically formed stalactite and stalagmite, and organically formed you talk about carbonaceous and calcareous. Okay, so make the diagram and explain through the diagram itself because you don't have much of the word limit is also there, no? Because you have to answer this question in a certain words. So you have already written introduction, one line regarding what? One line regarding how these rocks are something that are formed. You explain the processes. Then you have talked about what? Then you have talked about characteristic of the sedimentary rocks and types you can explain through the diagram itself. Okay, you can make the diagram. Here arenaceous you just mentioned at bigger sediments. Okay, porous in nature. Here you can mention argillaceous as what? Non-porous. And you can mention the point. Carbonaceous means rich in carbon, example coal. Calcareous, rich in calcium, example limestone. You can mention that in the diagram itself and explain through the diagram itself. Fine. Then because the question, if it is not asking so many things, then you can have explained these particular term. But since it is asking formation also, characteristic also, types also, then it is also asking about importance. So you have to make the diagram and explain through the diagram itself. Fine. Next you have to write about what? Next you have to write about importance. Importance of sedimentary rocks. So what in the importance, what you will write?
Fossil fuels.
Yes. The first thing, it provides you energy minerals. Energy minerals like crude oil. Then you can mention about coal, which you derive it from here. So it provides you energy minerals. Second thing, Industrial, yes, industrially important. Why industrial important? Because it provides you minerals like which type of minerals? As we discussed, it can provide you silica, it can provide you iron, magnesium, other element. All these elements can be provided, so it is industrially also important. Clear? So you can either you can club these 2 points together to write economic resources. You can mention heading as economic resources, and you can mention about both these points. Clear? So either you can mention it separately or you can mention it together. Okay. You can also talk about it is environmentally important. Environmentally important. Why? Because it helps in carbon sequestration. It helps in carbon sequestration. Environmentally important as it helps in carbon sequestration. That is why it is environmentally important. Carbon sequestration means anything that absorbs carbon. Okay, that is called as a carbon sequestration. Clear? So, for example, if the carbon that is dead and decay material, when dead and decay material they undergoes high temperature, we discussed they convert themselves into what? Fossils. If they doesn't undergo high temperature and pressure, what will happen? You see that decay material will release carbon in the atmosphere, and when carbon will release into the atmosphere, what will happen? Carbon dioxide concentration will what? Increase in the atmosphere. If carbon dioxide concentration will increase, what will happen? Greenhouse gas effect will be there. Carbon dioxide concentration will lead to greenhouse gas effect. So this fossils formation also protect us from where? This fossils formation also protect us from greenhouse gases. Clear? Any doubt regarding this particular thing? Then it is also important, it is providing you which type of resources? It is providing you which type of resources? Hydrological resources. Remember, we discussed arenaceous is which type of rock? Porous rock. Porous rock means groundwater and etc. is going to reside where? It is going to reside in these type of rocks. So it is going to provide you which type of resources? Hydrological resources. You can mention about water resources or you can mention about hydrological resources. The point, okay, you can mention. Clear? Next important thing that you see is, okay, what? It provides you also geological record. It also provides you which type of record? Geological record. Geological record means the Earth's evolution, Earth's history, how the rocks has been formed over a period of time, or Earth evolved over a period of time. This geological record is also being provided. Why? How this geological record is being provided?
Fossils.
Fossils, yes, okay. Any other thing? Any other thing? Let's say, okay, you are finding fossils. You can say that this fossils is from where? From Paleolithic period, Mesolithic period, or you are finding it from Harappan civilization, or you are finding this from nothing but a different period. So it provides you record of that. Any other thing? How it provides you geological record? As we discussed, how the sedimentary rocks are being formed? By deposition. Okay, which brings the material, which erodes the material and deposit it. We discussed rivers erode the material and deposits. Glaciers erode the material and deposits. So when the glacier was there at this area, which has eroded it and deposited it, clear? Like Earth was in ice age. When Earth was in ice age, you see a lot of glaciers were there. Now Earth is warming up. Glacier is now melting. So earlier glacier was present. Now it is not present. How you have this record? You have this record through formation of rocks. So this also provide you geological record, geological history that is there. Clear? So these are importance of. You can also mention about engineering and infrastructure. That also you mention that study of these rocks. Study of these rocks helps you in what? Study of these rocks helps in what? Helps in deciding which infrastructure to be built, which infrastructure to be not built. Okay, if the rocks are softer, then what will happen?
Landslides.
Then you can't create a big weight infrastructure over there, because rock are softer, it will break down. If harder rocks are there, then you can create bigger infrastructure over there, that is there. So it also helps in deciding which infrastructure you want to build, which engineering thing you want to build. So that also is that also is what you can mention regarding importance of sedimentary rocks. Fine. So what you have to do is first you have to start with the introduction. In the introduction, you can mention about what that's how sedimentary rocks are something that are formed. Then formation of sedimentary rock. Explain these processes in one line. Then what you have to do? Then you have to talk about characteristic of sedimentary rocks. Then you have to talk about what types of sedimentary rocks. Then you have to talk about importance of sedimentary rocks. Then lastly, what you have to do? Conclusion. Conclusion. So in conclusion, what you can write? In conclusion, what you can write? That sedimentary rocks are containing records of planet past, and it is also useful for providing various resources. So you can mention about hence sedimentary rocks provides information regarding Earth's evolution, and it also provides resources which are critical for modern development. So this is okay, one line you can write and you can end your answers. So this summarizes what sedimentary rock importance are here. It provides you resources which are very important, and also it has provides you geological history, past record, and etc. So it has summarizes that particular thing. Fine.
So can I add another point here? Like the nature of soil, sedimentary rock will give us nature of soil, like argillaceous rock is.
Yeah, you can add it depending upon the word limit, because already the question is asking too many things. Generally, you will get, if you get this question, you are going to get this question to write in 150 to 200 words. Okay? So that's why relating it with the soil, because soil is not being asked, relating it with the soil will add more points. So if it is being asked in more words, you can add. If it is not being asked, then you can leave it. Okay, fine. Then second question that was there. This was okay. Second question describes how the fault shapes the Earth's surface and causes earthquake by giving examples. Clear? So in here, introduction, how you will write, what are the keywords? First keyword is what? How fault is shaping what? Earth's surface, and how fault is causing what? Earthquake. And the last thing, you have to add it with the examples. Okay, so these are the two things. Now most of you, what you have done is you have tried to explain the types. That is okay, it is strike slip fault, normal fault, reverse fault. You have talked. But because the question is not asking you types of fault, you have to use the these terms, normal fault, reverse fault, but you have to explain it how it is shaping the Earth's surface. So in introduction, to talk about faults are the fracture or rupture on the Earth's surface where rocks moves, where rocks on either side move relative to each other, Clear? So faults are what? These are fracture or rupture on Earth's surface where rocks on either side moves relative to each other. Clear? Now this movement of rock, the movement of rocks can either be upward, downward, or in lateral manner, Okay, so this is the introduction what you have to write. That faults are what? Faults are fracture or rupture on the Earth's surface where rocks on either side move relative to each other. The movement of rocks can be either upward, downward, or in lateral manner. Clear? Clear? Now here you have to make a diagram. So you have to show this is one rock, this is one rock. Now, or rather, you should, okay, this is okay what? So show like this. This is one rock and this is one rock. Here this rock is moving what? Downward. This is okay, remaining as it is. Okay, this is remaining as it is. This rock is moving downward. Or you can make diagram like this, explaining this rock is nothing but okay what? Moving upward. So you can have either upward movement, you can have either downward movement, or you can have which type of movement? Lateral movement. Okay, you can have which type of movement? Lateral movement. So okay, a simple diagram you can make in order to indicate what is okay upward movement, what is upward movement. So what is upward movement, what is downward movement, and what is nothing but okay lateral movement. Clear? A simple diagram quickly you can make after introduction to explain. So this is how you have introduced your fault. Yeah. Now after making this particular diagram, you can explain the fault plays a crucial role in shaping the Earth's surface in following manner. Clear? So you can write how fault plays a crucial role in shaping the Earth's surface. Now you can write fault plays a crucial role in shaping the Earth's surface in following manner. Fine. Now, if you remember, we discussed the upper part of this is called as what? If you remember, we discussed the upper part is called as a host, the lower part is called as what? Garden. So you can mention this in the diagram that this is okay host, this is nothing but okay garden, etc. You can mention that in the diagram itself. Here you can mention about what? Here you can mention about block mountain. Here you can mention about what? Rift valleys. So when you are explaining this, then the examiner will come to know. You know what is exactly happening with the block mountain. So you mention about horse, you can mention about garden, you can mention about block mountain, you can mention about nothing but rift valleys and etc. You can mention the higher part is going to create what? Block mountain, the lower part is going to create nothing but rift valleys. Clear? So now we are writing fault plays a crucial role in shaping the Earth's surface in following manner. How? What are the manner? The first point?
It will create block mountain.
Yes, block mountain. So first point you write regarding block mountain and explain the above diagram that one block mountain is formed due to what? It is formed due to normal fault. Just mention this normal fault. It is formed due to the normal fault. So the movement is going to what? Movement is going to be downwards. Normal fault is what? When movement is going to be downward. So we'll see nothing but okay, what type of fault is going to be formed? Normal, okay, fault. So this upper part is going to be called as what? So this is moving downward, upper part is going to be called as what? Block mountain. This is going to be called as what? Rift valley. Example of block mountain we discussed last class. Example of block mountain, Vosges mountain. Prelims questions we have discussed which is the best example of block mountain, Vosges mountain. You can mention about also Sierra Nevada. Sierra Nevada, because the question is also talking about which type. So here the question is okay talking about which one? You have to give examples. You have to give examples. So you have to mention examples. So talk about block mountains are created due to what? Due to the block moving downwards, due to one of the block moving downwards, and this type of fault is called as a normal fault, and it leads to creation of what? For example, you have Vosges mountain, Sierra Nevada mountain. Sierra Nevada where you have?
North America.
In North America, yes, okay, below in the Rockies, okay, as we discussed, here lies the Rockies, here lies the Rockies, and here lies the Sierra Nevada. So we discussed Cordillera, lot of different type and different system, different geological period are called as what? Cordillera, clear? So here you'll find Sierra Nevada. All these are example of which type of fault? Normal fault. The second, you can mention about rift valleys. So rift valleys is going to be what? The lower portion. The lower portion is going to be creating what? Creating nothing but okay, rift valley. Clear? So rift valley examples is, you can mention about Narmada. Yes, Narmada is an example. Then you can also mention about East African rift valley. So last class we discussed here the Africa, what is happening? You see creation of what? Rifting is happening. East African rift valley is an example of the rift valley. Clear? The third thing, you can mention about linear valleys. Linear valleys. Another thing that is going to be created is linear valleys. What is linear valley? Created due to strike slip fault. Created due to strike slip fault. Okay. So you can mention about okay, the linear valleys is created due to strike slip fault. Okay, that is okay there. Clear? Now what happens in a strike slip fault? We discussed okay, they slide past each other. Okay, they slide past each other. So this is okay one, this is okay another. They are sliding past each other. So what is happening? This rupture is created. This valley is called as what? This valley is called as a linear valley. This valley is called as a linear valley. This rupture, the region, the rupture region which is being created, this region is going to be called as what? Linear valley. Clear? So example is San Andreas fault. San Andreas fault is which type of example? It is an example of nothing but okay, linear valleys or strike slip fault or transform fault. So we discuss a special case of transform fault is what? A special case of strike slip fault is a transform fault. Clear? So this is linear valleys are something that are being created. Clear? There is okay another term that you can use while explaining called as a fault scrap. Fault scrap. Generally a step like or stair like. Okay, a step like or a stair like things. Normally what happens is okay, we discuss when one of the blocks will move downward. What will happen? You will see on the edges, you will see slide okay, dip edges, but sometimes due to erosion, you will see okay, this can be formed like this. So the lower part becomes what? This is a fault scrap. This is a step like things okay, that is okay being formed. So instead of okay clear edge, you will see a step like edge is going to be formed, which is okay referred as what? Fault scrap, which is referred as a fault scrap, a step or stair like things okay, that is okay there. So these are okay what? These are okay the points you can write that how fault is shaping what? How fault is shaping the earth's surface. Okay, so how fault is shaping the earth's surface? Fault is leading to the formation of block mountain. Fault is leading to formation of rift valley. Fault is leading to formation of linear valleys. Fault is leading to formation of a fault scrap. Okay, so you are using all these terms what you have explained. So you explained the normal fault, you have explained the strike slip fault, but you don't have to explain the types. You just have to mention what strike slip fault is leading to form, what normal fault is going to form. So you have to explain this in this manner. Clear? Now the second part of the question says what? Yes, how it is causing the earthquake. How fault is, we discussed how fault is shaping up the earth's surface. The second is how fault is shaping up the earthquake. Clear? So now the second part of your answer should be what? Second part of your answer should be the fault causing earthquake. So how fault is causing the earthquake, that you have to explain. Clear? Now what happens in fault? Since block move upward, downward or laterally. So here we are saying that the block moves either upward, downward or in lateral manner. This movement are sudden and rapid. These movements are sudden and rapid. Which causes what? Which causes release of energy. And this release of energy leads to generation of seismic waves, which causes earthquake to occur. So this is what you have to explain. So in faulting, what happens? The block move either upward, downward or in a lateral manner. This movement is sudden and rapid, which lead to what? Which lead to release of energy. Release of energy causes generation of which type of wave? Seismic wave. And this seismic wave causes generation of what? Earthquake. Clear? So as we discussed, one of the important examples of earthquake, we have discussed which fault? San Andreas fault. We discussed another fault, if you remember, Anatolia fault. If you remember, we have used this term Anatolia fault. Where Anatolia? Where is Anatolia? In Turkey. You remember Turkey, we have used this term Anatolia fault lying in Turkey, San Andreas fault lying in California. So those are the examples where you see faulting is causing what? Faulting is causing the earthquake. Yeah. After this, conclusion. Hence, faulting leads to landscape evolution, resource formation, and also provide geological record of the earth. Fine.
So how does it provide geological record?
Like whenever earthquake is occurring, whenever block mountains are being formed, okay, when it has been formed, like we have determined the very old fold mountain. Remember old fold mountain, which is generally formed recently mountain. Clear? So if you see on the basis of period, we have classified mountain ranges into what? On the basis of period, Precambrian mountain range, then Caledonian, Assyrian. Okay, we have divided the mountain ranges into period. No, so how we have come to know that these mountains is formed in this period based on nothing but based on geological record. So geological record, how you are going to get?
Carbon dating on rocks.
Yeah, carbon dating on rocks. So what will happen when faulting occurs? What will happen? You see tensions are being created, compressions are being created, thrusting is being created, okay, which lead to what? Sedimentary rock changing into metamorphic rocks, okay, or metamorphic rocks changing into what? Igneous rocks. Erosion will happen, another thing will happen. So this is okay how it works also regarding geological records.
So for example, metamorphic rock has been turned into igneous again. So how will we know it was metamorphic before?
How you will know it was
metamorphic before?
When volcanic eruption has happened. Volcanic eruption will happen. In volcanic eruption, what can come out? carbon can come out. You can find the age based on carbon.
Okay.
Okay, so you can decide before it was this eruption was not there. Okay, before here different rocks were there. Then they have been decomposed, and after that what happened? Magma was formed, and this has led to volcanic eruptions. So this is how you're gonna explain what you're gonna explain the answers. Fine. So any doubt now how to write it? So write regarding introduction. That's why I'm telling you to identify keywords. The keywords will give you your body. That what you have to explain in the main answer. That how fault is shaping the Earth's surface and how fault is causing nothing but a earthquake. Clear? So you have to identify the keywords and then you have to write that in case of your answer. Fine. So in the last class we were discussing about concept of volcanic eruptions, and we discussed with you the types of volcanic eruption. What are the types of volcanic eruption?
3 types. Types of eruption, frequency, and magma.
Yeah, based on frequency, what are the classification you have?
Active, dormant, and extinct.
Fine. And based on the mode of based on how they are erupting, you have a classification.
Fissure and vent.
Yeah, fissure and vent type. And lastly, you also have classification based on types of lava. Based on types of lava that is coming out. Andesitic, and basic. What is the difference between a shield volcano and composite volcano? What is the difference between a shield volcano and composite volcano?
So composite volcano, there will be magma eruption near the vent.
In composite, we discussed andesitic volcano is also referred as what? Composite volcano. So andesitic volcano means which type of lava is going to come out? Acidic lava is going to come out. So composite volcanic means which type of lava is going to come out? Acidic lava. And this lava will not spread much. This lava will come out in an explosive manner. We discussed acidic lava comes out in which manner? Explosive manner. On the other side, we have discussed the second part, which is a shield type. So shield type, okay, you have which one? You have magma that is coming out is highly fluid, not viscous in nature. It is highly fluid, and here you will see which type of eruption? Fissure type of eruption. So that difference we have discussed between shield volcanoes as well as and the composite volcanoes. Clear? Now we'll move on and we'll discuss the positive and negative effect of volcanic eruption. So last class we have discussed that volcanic eruption mainly occurs where? Volcanic eruption mainly occurs where?
Plate edges.
Yes, okay, at the margin of plates. It can be either convergent boundary and it can be either divergent boundary. So you can see it can occur convergent boundary or it can occur in divergent boundary. But we discussed some volcanic eruption can also occur in interior of plates sometimes, and this type of volcanic eruption is called as what? Hotspot volcanism. So before moving to this hotspot volcanism, first we'll discuss what is important, what is positive and negative of volcanic eruptions. So in positive, what you see, new landforms are formed. With volcanic eruption, you see new landforms are formed onto the Earth's surface. What are the landforms you are seeing? Like plateaus, volcanic plateaus. You are seeing volcanic mountains. You are seeing ridges under the ocean. We talked about sea mound. So all these new landforms are formed due to what? Due to volcanic eruption. So again, like we discussed, a question was asked how fault is leading to what? Shaping the Earth's landscape or Earth's surface. Like that question can be also asked how volcanic eruption is leading to what? Shaping the Earth's surface. Okay, so you have to explain what? You have to explain volcanic mountain, volcanic plateaus. You have to talk about ridges. You have to talk about sea mound. So all these particular things, you can also mention about islands, volcanic islands. This is also being created. Last class we discussed Japanese island, Indonesian island, Aleutian island. So even volcanic islands are also being created. That is okay. Clear? Next is, yes, it brings out minerals. Whenever volcanic eruption happens, it brings out new material, new minerals onto the surface. Which type of new material? Which type of new material? As we discussed, iron can come out, gold can come out, silver can come out, silica can come out, aluminium can come out. All these comes out onto the surface because of what? Because of volcanic eruption. So that's why these new mineral resources are brought onto the Earth's surface, and they are held where? They are present where? What we call as a metallic core. So these are present where? These are present in a metallic core. These minerals are present where? These minerals are present in a metallic core. Clear? Now, when these volcanic rocks get eroded, then what will happen? It leads to formation of what we call as a fertile soil. It leads to formation of which type of soil? Fertile soil. Clear? So when these rocks are eroded, volcanic rocks are eroded, it leads to formation of which type of soil? Fertile soil. And the soil can be used for what? Can be used for, yes, cultivation. Like you have a black soil. We discussed black soils are found where? In Deccan Plateau region. So here Deccan Plateau, basaltic lava, when it is eroded, what is being formed? Black soil, and black soil is used for cultivation of cotton, can be used for cultivation of sugar cane, any moisture retentive crops, okay? The crop that requires more moisture, moisture retentive soil. The black soil is referred as a moisture retentive soil. So this can be also used. So this is okay, another importance of volcanic eruption. Next, another thing that we discuss is, okay, this can help in global cooling, environmentally good. Global cooling. Why global cooling? So you have a certain gases which is referred as what? Greenhouse gas. You have gases which are referred as what? Greenhouse gas. Which are the gases referred as a greenhouse gas? Carbon dioxide, methane. You have, okay, other gases, okay, which are referred as a greenhouse gases. These are responsible for global warming. But from volcanic eruption, you will see sulfur dioxide is being released, which is responsible for what? Global cooling. And from here also a lot of dust particles are being released. Ashes are being released. So sulfur dioxide is responsible for cooling. Dust particle and ashes are also responsible for nothing but cooling. So volcanic eruption also helps in which type of cooling? It helps in global cooling. Clear? Now, what happens is, okay, when these dust particle and ashes spread into the atmosphere, what happens? They block the sunlight reaching to the Earth's surface, because, okay, they do not ensure that the atmosphere is transparent. Remember, we discussed earlier that the atmosphere is transparent to whom? Transparent to solar radiation, because solar radiation comes in the form of short wave, and atmosphere is, okay, what? It is blocking or it is absorbing the long wave terrestrial radiation. Remember this, we have discussed in first class itself. Why Mercury is not the hottest? We discussed why Venus is the hottest planet, because Venus has an atmosphere, Mercury do not have any atmosphere. So whatever the sunlight Mercury is receiving, those sunlight is, okay, what? Not being absorbed by the atmosphere of the Mercury, because Mercury do not have any atmosphere. So whatever the solar radiation is coming, this solar radiation is coming in the form of short wave. The solar radiation atmosphere allows them to, okay, reach to the Earth. But whatever the Earth is radiating, that comes in the form of what? That comes in the form of terrestrial radiation. And these radiation are generally absorbed by whom? Absorbed by the atmosphere. Clear? But if the solar radiation itself is not reaching to the Earth's surface, what will happen? Earth will not get heated. When Earth will not get heated, what will happen? It will not emit the radiation. When it will not emit the radiation, atmosphere will not be able to absorb. When atmosphere will not be able to absorb, what will happen? Temperature will come down. So that's how, okay, what will happen? Global cooling happens, and that is, okay, another importance of volcanic eruptions. Clear? So volcanic eruption led to release of what? Release of dust particle, ashes, sulfur dioxide, and etc., which leads to what? Which leads to global cooling. Fine. Clear? Now, what are the disadvantage of volcanic eruption? Last class we discussed one disadvantage of acid rain. Yes. So as we discussed, it releases gases like SO2 and NO2, nitric oxide, which when react with water forms your sulfuric acid and nitric acid, which causes the acid rain. This causes the acid rain. Fine. Normally, we discussed, okay, when something is acid and when something is a base. When something is acid or when something is a base, we try to measure the pH value. So generally, pH value 7 is referred as what? Neutral. It is referred as a neutral. More than 7, it is base. Less than 7, it is going to be called as what? Acid. Okay. So generally, in chemistry, what you will find is what? To find whether a substance is acid or a base, okay, or neutral, you measure the pH value of a substance. pH value 7 indicate neutral thing. More than 7, it is going to be base. Less than 7, it is going to be what? Acid. Yeah. pH is okay. pH is okay. Basically, we are trying to determine hydrogen concentration. The more the hydrogen concentration, more will be what? More acidic the solution will be. Like okay, here, like you are taking this substance H2SO4. So in H2SO4, what is present? Hydrogen is present. So you are trying to determine the concentration of what? Concentration of hydrogen. That is called as a pH. Yeah. So you are trying to determine the concentration of hydrogen. So more the hydrogen concentration means what? More will be the acid. Less the hydrogen concentration means what? Less will be nothing but okay, acid. That is okay. What you have to keep in mind. In base, you will generally have which? Okay, OH concentration. You generally have OH concentration. That is okay. What you are measuring in the base part. So less hydrogen concentration means it is going to be base. More hydrogen concentration means it is going to be acid. Clear? Any doubt regarding this one? So what you find is, but in when we call the rain as a acid rain, so normal parlance we say that okay, pH value 7 is neutral, more than this is base, and less than this okay is called as what? Less than this is called as a acid. Clear? So when we call the thing as a acid rain, if okay the water pH is going to be what? Water pH is going to be less than 7, then it should be what? Then it should be called as nothing but okay, acid rain. But this is not how it is. This is not how it is, because normal rain is slightly acidic in nature. The normal rain that occurs is slightly acidic in nature. Why normal rain is slightly acidic in nature? Because water already reacts with what is present in the atmosphere? Carbon dioxide. Okay, what is present in the atmosphere is carbon dioxide. So when water reacts with carbon dioxide, it forms carbonic acid. It forms carbonic acid, and that's why the normal rain is slightly acidic in nature. Clear? So when we call it as an acid rain, so normal rain pH value is how much? Normal rain pH value is around 6, or okay, we say 5.8 to 6. So this is a normal rain pH value. So when we call it as an acid rain, when pH value decreases below 5.8, when pH value decreases below 5.8, then we call it as which type of rain? Acid rain. Clear? Any doubt regarding this particular thing? So acid rain does not mean that okay, that the value of the pH value of water is less than 7. No, acid rain means when pH value decreases below what? Below 5.8, then it is called as a acid rain. Clear? Because normal rain itself is okay. What? Normal rain itself is a slightly acidic in nature because of the formation of carbonic acid. So normal rain is slightly acidic in nature. Clear? But when pH value further decreases, then we call it as what? We call it as a which type of rain? Acid rain. Clear? Any doubt? So UPSC has asked this question, okay, regarding prelims, acid rain, which when we call it as a acid rain, so its pH value has to go to nothing but okay below 520. Fine. Then second problem.
Air travel disruptions.
So second negative point is earthquake. Volcanic eruption can generate what? Volcanic eruption can generate earthquake. Clear? The third thing, it can release harmful gases and pollute the environment. Harmful gases and pollute the environment. Pollute the environment. Clear? So these are okay. What? These are nothing but okay important negative point that you have to keep in mind. So volcanic eruption has a positive thing also. It is leading to many good thing also, like global cooling, new landform formation, minerals coming out on the surface. It is also leading to formation of new kind of soil, fertile soil. But on the other side, it is also leading to what? Acid rain. It is also leading to what? Earthquake. It is also leading to nothing but okay harmful gases in the environment, which okay pollute the environment. So these are okay problems with what? These are problems with the volcanic eruption. Fine. Any doubt regarding this one? Now there are two other terms that you have to keep in mind. One is hot spring and another is called as a geyser. Now fine. Let's say this is how the convectional current are generated in the mantle, and this magma is something that is coming out. But magma does not again have a sufficient strength to come out. That's why magma is going to what? Spread. Remember batholith? We discussed magma is going to what? Spread. So this magma is something that is okay spreading. Now this magma, when it spread, it is hot in nature. Temperature is very high. Now this magma is coming in contact with what? Contact with the water. This water is okay present with groundwater. This water is present where? In the porous rocks. So this magma is now coming in contact with what? This magma is now coming in contact with the water. Now what will happen to temperature of water? It will increase. So this is referred as what? This is referred as a hot spring. When okay you will see high temperature. When you will see high temperature of water, groundwater inside the earth, that is going to be referred as what? That is going to be referred as a hot spring. Clear? Any doubt regarding this one? Now what if temperature increases, temperature of water increases more? If magma is too hot, temperature of water increases more, what will happen? This water will convert into what? This water will convert into vapor form. This water will convert into steam form, vapor form. So when temperature further increases, this water will convert into steam form or vapor form, and as a result you will see steam coming out from the interior of earth. Okay, you will see the steam or vapor coming out from nothing but okay interior of earth. This is referred as what? This is referred as a geyser. Clear? So these two terms okay also you have to keep in mind. One is called as a hot spring and the second is called as a geyser. So what is a hot spring? When magma comes out and comes in contact with the okay water inside the earth, the water gets heated, and this heated water is referred as what? This heated water is referred as a hot spring. And when this hot spring converts into what? That's water that converts into steam, vapor coming out from the Earth's interior, then it is going to be called as what? It is going to be called as a geyser. So some of the important regions where you will find the hot spring or geysers is Iceland, Yellowstone region of USA, Yellowstone region of USA. Yeah. You will also find in New Zealand. Some of the most important hot spring and geyser you are going to find in these regions. Okay, so Iceland region, Yellowstone region of USA, New Zealand region. There you are going to find the hot spring and geyser. Clear? Now, let's say if this is a Earth surface and this this is a convectional current that is generated in the mantle region. It makes Earth's interior what? It makes Earth interior more hotter because of magma coming out, spreading like this. It makes the Earth's interior more hotter. When Earth's interior becomes more hotter, what will happen? What will happen? You'll see temperature difference between here and temperature difference over here. Clear? Now, when this temperature difference can be used to generate energy, then such type of energy is referred as what? Geothermal energy. Then such type of energy is referred as a geothermal energy. Clear? So when this temperature difference which is present in Earth's interior and onto the surface, when this temperature difference we are trying to use to generate energy, then such type of energy is going to be called as a geothermal energy. Geothermal energy. So geo means what? Earth. Thermal means what? Temperature. So energy that is generated due to difference in temperature is going to be called as what? Is going to be called as a geothermal energy. It is which type of energy? Renewable energy. So you know that now we are trying to promote which type of energy? Renewable energy, because we want to reduce our dependence on fossil fuel, etc. So one such type of energy that can generate is called as what? That can be generated is called as a geothermal energy. That's why in mains examination you can get a question like this. You can get such type of question in the mains examination. Assess the geothermal energy generation potential in India. What are the problem in generation of such energy? Clear? So that type of questions you can get in the case of mains examination. Clear? So wherever you see nothing but wherever you see India can utilize its geothermal potential to generate energy, that area you need to locate on a map, and then you have to explain what? Then you have to explain what are the problem that is there in the generation of such energy. For example, one of the important regions where we are talking about where we are talking about generation of geothermal energy is here. This is called as a Puga Valley in Ladakh. This is an important site for generation of what? Generation of geothermal energy. India is now trying to explore, trying to assess, trying to utilize the geothermal potential energy over here. This is called as a Puga Valley in Ladakh. Like that, you will find also in Gujarat, this region, where you will have geothermal energy potential. So you have to find, on a map you need to locate India's area which have the geothermal energy potential, and what is the problem in generation of such energy. Clear? So if temperature difference, if it is too high, then only what will happen? Then only we can commercially develop what? Geothermal energy. Otherwise it is difficult to. Secondly, it is expensive to generate such type of energy. So that is another problem with generation of geothermal energy. Clear? So you might get a question also on geothermal energy in the case of examination. So geothermal energy means what? Energy that is generated due to temperature difference between Earth's interior and on Earth's surface. That is called as what? That is called as a geothermal energy.
Hot spring geysers are present in Ladakh, sir.
No, hot spring and geysers are not present in Ladakh.
In India, no.
India does not have much region of volcanic eruption. We have Andaman and Nicobar, that is volcanic island, only that is prone to volcanic eruption. Rest of the regions are not prone to volcanic eruption. So that's why we do not have much of hot spring and geyser concept. If this would have been there, easier generation. Geothermal energy can be easily generated.
So where we find earthquake, only there we find hot spots and geysers?
No, not necessarily where you will find earthquake, only wherever you will see magma eruption. Like you see Earth's interior, hotspot volcanism, there also you can see what? There also you can see creation of what? The hot spring and geyser that is there. Clear? So hot spring and geysers can be wherever volcanic eruptions are going to be there, not related with earthquake. A volcanic eruption may trigger earthquake, that is a different thing. But wherever volcanic eruptions are there, there you can see hot spring and geyser formation. But hot spring and geyser formation also requires what? Huge amount of what? Huge amount of water. Clear? So along with the volcanic eruption, you also requires what? More water to be stored. If lesser water is there, then what will happen? You will not see creation of food.
Did you find this in Antarctica, sir?
Which one?
The geysers and hot springs?
No, geysers and hot springs you don't find in Antarctica because of no volcanic eruption in that region. Fine? No volcanic eruption happens in that region. So that's why you don't find the geyser. Antarctica is what? A continent. Continent. So you are seeing what? You are seeing nothing but their hotspot volcanism is not available. On the plate boundaries, you don't see much of nothing but volcanic eruptions over there. Right? So that is the reason why you don't see much of volcanic eruption. Fine. So here you will find so basically this is how you are seeing formation of what? Formation of nothing but hot spring and geyser. So you can see this is where presence of what is there? So here you are finding what? Here you are finding the porous rocks. Here you are finding porous rocks. Here what is stored? Water is something that is stored. What is here? Magma. Heat. Magma is heating what? This water. What is being generated? Steams are something that are being generated. This steams is referred as what? This steam that is coming out is referred as what? Geyser. And this hot water that is present is called as what? Hot spring. Clear? So this hot water that is present is called as a hot spring. Clear? Now,
Sir, is there a possibility that after a time, when due to the temperature difference, what if all the water inside a hot spring gets evaporated?
All the water inside?
That area gets evaporated.
All the water get evaporated? No, there is always a water cycle, no? Like water is being evaporated. What is happening? Cloud formation, condensation, Then what is happening? Rainfall. Rainfall means what? Again recharge of what? Groundwater. So the cycle is continuing. So you can see this. So you see where are some of the important hot springs that are located. You will find that where you will find that in case of the Japanese region. You will find that in case of nothing but Japanese region. You can find this in the case of nothing but Australia, the Lodzi Spring. You will find that particular thing. Then you will also find, as we discussed, Yellowstone region of USA. So Yellowstone regions, that will find. There you will find a lot of hot spring. Then you will also find in Colorado, Idaho. All these are USA only. Then so these are what? These are the important regions where you will see formation of what? Formation of hot spring. Fine. So that's why the question might come: what is hot spring and what is nothing but geyser part. Clear? Another thing. So you can see this is a geothermal map of India, where we have a potential to generate what? Where we have potential to generate energy. Just quickly make this map. Make this map. Show this region, as we discussed, Gujarat and the Mumbai region. This region is having geothermal potential. You can see here it is written as Kuga. Kuga is what? This is there in the Ladakh Kuga Valley we have talked about. So that lies over here. So, just make this diagram, Uga and Manikaran, those are the two regions. You can mention over here, Uga and Manikaran. Then these are what? These are nothing but important regions, that is there. Then here, Gujarat and Mumbai region. This whole belt of Vindhyan, Satpura region, and some certain over here, Mahanadi and Godavari basin, where we have Where we have geothermal potential. Just make this diagram and just mention this particular statistic. 10,600 megawatt. 10,600 megawatt is India's geothermal potential. megawatt is India's geothermal potential. Yeah? Maximum potential India can generate this much energy. Yeah. So why do you see this whole this whole region and this whole region where we have where we have this entire region where we have the more geothermal potential? What is the reason? Yes, compression there is taking place. When compression will happen, what will happen? You will see things will come together. When things will come together, what will happen? Temperature will increase. Clear? So what is happening in Himalayan region? What is happening in Himalayan region? Compression is something that is happening. Clear? Because of this compression, what will happen? Things will come together. When things will come together, what will happen? When things will come together, what will happen? Molecules are closer. When molecules are closer, what will happen? You see, heat will increase. Heat will increase. That is the reason. Here also you will see this region, as we discussed, submerging. If you remember, west coast of India, we discussed it is submerging, going down. When it is going down, what will happen? It is exposed to high temperature. Anything that is goes down, it is exposed to high temperature. So that's why this region is having what? Region is having high potential. This region is a zone of faulting. Fault is being created. Vindhyan Satpura region, fault is being created. So India have a geothermal potential region over here. Clear? So when question comes, in the mains examination, assess the geothermal potential of India. Make this diagram. Explain that India have a geothermal potential in the northern part, northeastern part, in the middle central part, in the western coast, and some around Godavari and Mahanadi basin. So you have to mention about these areas where India have geothermal potential. And India is building the geothermal plant in these two, Uga and Manikaran. The two upper side that we have, Uga and Manikaran, there we are trying to build.
So what is that name Delhi?
This is Sohana, S-O-H-A-N, Sohana. This is Camden. This region is Ganeshpur. Godavari basin, Mahanadi basin. This region is Surajpur. So these are some of the sites for geothermal potential, where we are trying to set up geothermal power plants.
So why is there geothermal energy near the water basin? Near the water basin of Godavari and Mahanadi?
This region, like Godavari and Mahanadi, okay, basin. Now this is okay flowing through where. Now these rivers, okay, you'll see flowing like this. These rivers, Godavari is flowing like this, Mahanadi originates over here, flows like this. Clear? Now what is happening over here is, okay, what these are creating a basin. Clear? These are creating a basin means lower part. Basin, how it is being created? Rivers are flowing through what? Rivers are flowing through what? Not, they are creating what? Like this. This is a earth surface. Now when you create what? When you create this, then what will happen? Then only rivers will flow, no? Rivers will need a path to flow. So that path will be, okay, what, lower than the surface. Earth surface is, okay, this one, this is lower than the earth surface. As you go down, what will happen? As you go down, what will happen? Temperature will what? Increase. So that is the reason why we have a potential. Fine.
So what was the geothermal potential of India?
10,006. Fine. Now, question number 6. Here it is talking about define mantle plume and explain its role in what? Plate tectonics. So this question has been asked in 2018 paper. In the mains examination, this question has been asked. The define mantle plume. Define mantle plume and explain its role in plate tectonics. Answer you have to write in how many words? 150 words. Okay, so this is okay question that has been given. Now this is related with what? This is related with your volcanic eruption. This is okay related with what we call is a volcanic eruption. Define mantle plume and explain its role in plate tectonics. Which type of volcanic eruption? The next that we have to discuss, which is called as a hotspot volcanism. So it is related with which type of volcanic eruption? Hotspot volcanism. Fine. Fine. Now, first of all, there is a difference between the plate margin volcanic eruption and hotspot volcanism. Volcanic eruption and hotspot volcanism. What is the difference? The first major difference between these two, plate margin volcanic eruption and hotspot volcanism, is that their location is not fixed. Their location is not fixed, but they generally have a fixed location. So they generally have which type of location? Fixed location. Hotspot volcanism generally occurs at a fixed location on the Earth's surface. Their location is not much changing. Clear? But plate margin volcanic eruption, their location keeps on changing. Why their location keeps on changing? Why their location keeps on changing? Because we discussed plates are continuously moving. Sometimes plate will move like this, sometimes plate will move somewhere else, sometimes plate will move somewhere else. So when plates are continuously moving, the location of volcanic eruption is going to be changed. Okay, so it is not going to be fixed volcanic eruption, but hotspot volcanism occurs where? Within the interior of plates. So generally what you see is, okay, their location are relatively fixed. Fine. So last class we discussed in your sounds. So here the plate margin is what? Plate margin is, okay, at this point you will find what? Location keeps on changing, volcanic eruption location. This is relatively fixed location. Okay? At plate margin you will see the large convectional current being generated. Large convectional current being generated. Generally at hotspot volcanism you will see small convectional current being generated as compared to what? As compared to the plate margin. So here you will see generation of small convectional current. Clear? So in plate margin we are seeing subduction is happening. So because of subduction what is happening? Plates are melting. When plates are melting it is leading to lot of magma, lot of convectional current generation. So that's why here you will see large convectional currents are going to be generated. At the hotspot volcanism generally you are going to see which kind of convectional current? Small convectional current generations. Fine. The third thing, the third type of volcanic eruption that you have is the third type of difference that you have is between plate margin volcanic eruption and hotspot volcanism is in this type of eruptions, okay, you don't see what we call as so the small convectional current that is generated in the hotspot volcanism is referred as what? This is referred as the term mantle plume. So the small convectional current that is generated in the hotspot volcanism is referred as what? Is referred as the term mantle plume. So when it is talking about defining mantle plume, it is talking about what? It is talking about convectional current that is generated in the interior of Earth. So that is what we call as a hotspot volcanism or generation of mantle plume. So what difference lies between plate margin volcanic eruption and hotspot volcanism? This occurs not at a fixed location. This occurs generally at what? Fixed location. Here large convectional current are generated. Here what is happening? Small convectional current are generated. These small convectional current are called as what? Mantle plume. As we discussed, they are always occurs on the edges or the margin. Hotspot volcanism occurs at the interior of the plates. It occurs at the interior of plates. So they occurs at the boundary, edges or the margins, while this occurs at the interior of plates. So primarily this is difference that lies between. This is the difference that lies between hotspot volcanism and plate margin volcanic eruptions. Fine. Now, because of this difference, Now this is okay. What? This is your Earth surface. While this is okay your mantle region. Now from mantle region we discuss small convectional currents are going to come up, and the small convectional currents will be spreading like this. Now this is okay taking which shape? Mushroom shape. Okay, so the mantle plume is like this shape only. Mantle plume is like this. A small convectional current rising like this, and then okay spreading like this, taking which type of shape? Mushroom shape. So this is okay what we referred as what? This is what we referred as the mantle plume. Fine. So if you see the figures of mantle plume, so how you are seeing this particular, these are rising like this and then spreading like what? Spreading like this. So it is in which shape? Mushroom shape. It is in which shape? Mushroom shape. And what you are finding is this is called as a plume. This is a plume that is rising, and this plume is rising in which region? Mantle region. So that's why it is referred as what? It is referred as a mantle plume. Clear? So this is a small convectional current that is rising, spreading like this, and that is what we call as a mantle plume. And this is occurring where? Not at the boundary. It is occurring at the middle. That's why it is called as which type of volcanic eruption? Hotspot volcanism. So that's why it is called as a hotspot volcanism. So that's what you have to define over here when the term define mantle plume that is coming. What you will define? How you will define this term?
These are small convectional current generating from the mantle region.
Yes, these are small convectional current that are generating from which region? From the mantle region, and rising. These are okay, rising from the mantle region and rising near to the Earth's surface and spreading and in forming which type of shape? Mushrooms. So this is okay what happens in case of nothing but okay hotspot volcanism. So hotspot volcanism occurs due to which type of thing? It is occurring due to small convectional current which are referred as what? Mantle plume. Fine. Now there are certain locations on Earth. Which are prone to hotspot volcanism. Because we discussed these are fixed locations, relatively fixed location, not changing. So there are certain locations on Earth which are prone to hotspot volcanism. One is Hawaiian Island region. That is okay. One of the reasons prone to hotspot volcanism. Another we discussed is Reunion Island. Again, this is prone to hotspot volcanism. So these are some of the regions on Earth which are more prone to hotspot volcanism. Hawaiian Island, Reunion Island. These are regions prone to hotspot volcanism. Fine. Where do you find these islands? Now you can see these islands, lot of islands here is mentioned. Now, so you can see last class we discussed that Indian plate is broken from which plate? Indian plate is broken from which plate? African plate. And we discussed, okay, then Indian plate has moved towards what? Moved towards Eurasian plate and collided with the Eurasian plates. So you can see this region, okay, this is Maldives region. This is, okay, Dioga-Garcia region, which is, okay, occupied, controlled by UK. This is Sicilies Island. This island is referred as the Sicilies. This is Comoros Island that you are finding. And here you will find which island? Reunion Island. So this is one of the reasons which is prone to what? Which is prone to hotspot volcanism. It is one of the reasons that is prone to hotspot volcanism. So Indian plates. So Indian plates has broken like this, and when it was passing through this region, this reunion, currently where reunion island is there, when Indian plate was passing through this region, then what had happened? Volcanic eruption has occurred on the Indian region, and because of this volcanic eruption, we see formation of which plateau? Deccan Plateau. So when we come to Indian geography, we discuss Indian Deccan Plateau is formed before what? Before formation of Himalayas. Because Himalayas is formed when collision is happening, then okay you see formation of Himalayas, but Deccan Plateau is formed before the formation of Himalayas. So this is okay occurring due to reunion islands. So all these islands are very important. UPSC has asked these questions. Again they can ask you question. If you are going through the current affairs, where the Prime Minister is recently visiting, which two region? Prime Minister is recently he has gone for foreign visit from 20. He is going to foreign visit from 23rd to 26th of July. In which of the region he is visiting? One is Maldives, yes. Another is UK. So UK and Maldives. So since he is going to the Maldives, again question can come. This territory is something that is okay news. And Maldives is very also important from India security point of view. It is very important, very close to India, so important from India's security point of view. Clear? So UPSC has asked these questions regarding island, arranging island. They have the names, map-based question, Comoros Island, Sicilies Island, Maldives Island, and ask question, arrange them east to west or west to east, okay, or north to south. Such type of questions can be asked in the case of examination. Those are map-based questions. Fine. Another important island, as we discussed, is what? The Hawaiian Island, which is also prone to hotspot volcanism. So now here can you see this region? This is called as which type of ridge? Hawaiian ridge, yes. Okay, this is referred as which type of ridge? So this is referred as a Hawaiian ridge. Here we will find which type of island. This is where Hawaiian island are something that are presented. Last class we discussed this whole region is referred as what? Ring of fire. So this is ring of fire where you see lot of volcanic eruption are happening. But Hawaiian is in the interior. It is not at the edges. So interior, we discussed which type of volcanic eruption is going to happen. Hotspot volcanism. Currently this Hawaiian is under the control of US. US is controlling this particular island, Hawaiian island that is okay there. So it is found in the middle of the plates and it is prone to which type of eruption? hotspot volcanism. Again, large amount of mantle plumes you are going to get over here. So this is why UPSC has asked these questions regarding hotspot volcanism. So if question comes, define mantle plume and explain the role of this in plate tectonics. What you're going to write? That mantle plumes are what?
Small convectional current.
These are small convectional current. Where it is generated?
Inside or
Interior of Earth. At which point? In the interior of plates you write. Not interior of Earth. Interior of plates. Where it is being generated? Interior of plates it is being generated. So it is a small convectional current rising from mantle region and spreading at the top, taking a which type of shape? Mushroom shape. Right? And then its role in plate tectonics, how it is affecting the plate tectonics. So we'll cover the plate tectonics part later because we have to get started with the plate tectonics. So remember that two type of volcanic eruption. So if question comes, what is the difference between plate mount boundary volcanic eruption and the hotspot volcanism? What difference you going to write?
No fixed location.
Yeah, plate boundary is not a fixed location. Hotspot volcanism is what? Fixed. Large convection current generated at the plate boundary. Small convection current are generated at a hotspot volcanism. Then yes, it occurs at the edges and it occurs at the base of the plate. Yeah. So those difference you have to keep in mind. Fine. So have a break and then we'll further continue. So the next part that we have is a volcanic landform. It is divided into two parts: extrusive landform as well as intrusive landform. Now, intrusive landform already we have discussed. These include what? Batholith, laccolith, leucolith, pacholith, then sills and dikes. So, if you remember, we discussed when lava will spread, it is going to form what? Batholith. When lava deposition will be vertical, it is going to be called as dikes. When it is horizontal, then it is going to be what? Sills. When it is wavy shape, it is pacholith. When it is okay, which shape? Saucer shape. Saucer shape is going to be which one? Leucolith. Yes, okay. And laccolith? Saucer shape. So these are okay, what? These are nothing but okay, different part we have discussed with regard to what? With regard to intrusive landform. So this we have already covered. Now we'll okay take up which landform? Extrusive landform. We'll take up extrusive landform. So what is being formed okay due to volcanic eruption onto the surface? Extrusive landform. So in extrusive landform, what you find is one important thing is crater. So one thing that you find is a crater. And crater can be of different type. Caldera, another important thing that you're going to find is a caldera. Clear? Then you will also find the highlands or domes. This also you will find in the form of extrusive landforms. So you'll find crater, you'll find caldera, you'll find okay highlands, or you'll find what we call as a domes. Fine. So what happens is, okay, let's say magma comes out, and let's say this is a earth surface. Let's say this is okay, earth surface, and this magma spread below the earth surface. What will happen? What will happen? Now earth surface is in contact with what? Hot magma. When earth surface is in contact with hot magma, what will happen? What will happen? Any substance when heated, what will happen? It is going to expand. Any substance which is heated is going to expand. Like okay, we discussed okay, heating milk volume will what? Expand in the vessel. So when you are in contact with the hot magma, what will happen? This earth surface will get heated, and when it will get heated, you will see a dome shape formation like this. This part of the earth surface will become what? A dome shape. So because of hot magma spread, this has now changed into a dome shape. Clear? Or might increase like this, which is called as a highland or a dome. For example, if you see the map, you will find here which type of island. Here you will find Ethiopian highland. This Ethiopian highland is formed due to what? Due to nothing but okay, magma spreading, and because of magma spreading, the earth surface has expanded, increased, okay, and this has led to formation of what we call as a highland. So one thing that you can find is highland or dome. Clear? So if the magma is spreading to a lesser distance, let's say if magma is spreaded only to this much area, then what will happen? You'll see this much area is heated, this area will not get heated, and the middle part is only heated, which led to expansion of the middle part, which led to dome shape formation. If entire region is heated, then what will happen? We'll see highland formation like this. Fine. Then there is a term called crater. What is crater? So let's say this is a vent. This is a vent through which volcanic eruption is coming out, and this region, this conical shaped region, which is okay there at the top of the vent, is called as what? It is called as a crater. The conical shaped vent at the top is called as what? Is called as a crater. This is okay referred as a crater. Clear? Sometimes this crater or depression can also be created due to the impact of meteorites. When meteorites hits the earth, comes to the earth, what will happen? When meteorite hits the earth, and because of this impact, okay, you'll see okay this type of depression is okay being created, vent is being created, which is okay what? Which is also called as a crater. Clear? So crater can be result of what? Crater can be result of meteorite impact also. Crater can be result of nothing but okay, volcanic eruptions. Clear? Now let's say this volcano become extinct. Last class we discussed volcano can become extinct. When volcano become extinct, what will happen? What will happen? No eruption. When no eruption, what will happen? When rainfall happens, what will happen in this region? Accumulation of water. This depression, you will see accumulation of water. This accumulation of water will lead to what? Formation of a lake called as a crater lake. This will lead to accumulation of water, which is called as a crater lake. So when rainfall happens, the rainwater get deposited in these conical shaped crater, and this is okay what we call as a crater lake. For example, in India, you will find a lake called No Lake. This lake lies in Maharashtra, which is which type of lake? Crater lake. It is a which type of lake? Crater lake. So when volcano become extinct, you will see the rainwater get deposited in this particular region, and such type of things are called as a crater lake. Fine. The next part is what? Caldera. What is caldera? So over a period of time, this crater get widened. This widened crater is okay referred as what? It is referred as a caldera. Okay. So this widened crater is referred as what? Caldera. So over a period of time, the crater get widened, and this widened crater is referred as what? Caldera. Fine. So there are two terms already. One term we have discussed is what? What is the difference?
Group of
Mountains. Yes. Okay. So don't get confused between the term caldera and cordillera. Cordillera is a group of mountain, while the caldera is a volcanic landforms. Okay. It is called as a volcanic landform. So cordillera, we have discussed mountain range, mountain system. Okay. So here you will find what? Here you will find caldera. So you can see this region is referred as which? Ethiopian highland. Okay, this region is referred as which type of island? It is referred as nothing but okay, Ethiopian highland. Why this Ethiopian highland is being formed? As we discussed, this highland is being formed because magma has spreaded. With magma spreaded, what will happen to Earth's surface? It get heated. When it get heated, what will happen? It will rise up, and this has led to formation of which type of island? Ethiopian highland. Clear? We'll also see so you can see this is a crater formation. So the point, where you see eruption of what? Eruption of nothing but okay, volcanoes. This is called as what? This is called as a crater. And as we discussed, when rainfall happens, water get deposited in this crater, and this is referred as which lake? Crater lake. This is referred as which lake? Crater lake. Clear? So this is okay, the crater from which you see volcanic eruptions are something that are coming out. Fine. You will also find caldera. So we discussed what is the difference between crater and caldera. Crater is going to be what? Smaller one. Caldera is going to be what? Bigger one. This part is what? This part is a smaller part is a crater. This bigger part is what? Caldera. Clear? So what is the difference? So when we discussed, when crater get much bigger over a period of time, it changes into what? It changes into caldera part. Fine. So this difference lies between crater and caldera. Also,
caldera hot springs it can be formed, sir.
in caldera.
It will become the water will come mainly.
But water is okay onto the surface, no? When it is being formed, when hot spring and geyser are being formed, when water is below groundwater, it is not surface water. It is groundwater. When groundwater is heated, then okay, you see hot spring and geysers are coming together. Right? Then you will also see something called, one more thing called as a cinder cone. Sometimes you will also see. So this is okay, what? This is okay, type of crater. This type of crater is known as a cinder cone crater. This type of crater is a cinder cone crater. Normally, how do you see a cone? This is a cone shape. This is a cone shape. Clear? This is which type of shape? Cylindrical shape. So when the vent is like this, when the vent is cylindrical in nature, then what will happen? When vent is cylindrical in nature, this part is called as what? Crater. The upper part, okay, we discussed, is called as a crater, and this part is called as a vent, from where the volcanic material are something that are coming out. Clear? So when this is cylindrical in nature, then you will see which type of crater, cylindrical crater. But when you will see this type of eruption, like let's you invert this one. When you invert this one, what you are going to get? When you invert the cone, you are going to get this type. So when you invert this, you are going to get which type of cone? You are going to get this type of cone. So this type of cone is referred as which crater? Cinder cone crater. So crater can be of cylindrical type, crater can be of cone type, depending upon how the vent is being created, or how the whether it is linear in nature, whether it is cone in nature, how it is being created. You can have cinder cone, you can have cylindrical crater, different type of crater you can also see. Clear? Any doubt regarding this part? So this is all about what? This is all about your volcanic eruptions. So we discussed what is volcanic eruption, what is the type of volcanic eruption, advantage and disadvantage of what? Volcanic eruption, causes of volcanic eruption, then hotspot volcanism, then positive and negative of volcanic eruption. Also we saw different type of landform, intrusive landform and extrusive landform. Intrusive landform already we have discussed. Extrusive landforms are what? Your crater, your caldera, your island or toe. Clear? So those are creation of landforms. Now we are moving towards the exogenic. So we are now done with what? Endogenic. Now we are moving towards exogenic. So exogenic we have primarily two parts, two differentiation. We have divided it into what? Weathering and erosion. Yes. And weathering is further divided into physical weathering, chemical weathering, and biological weathering. And erosion we have divided based on their agent. It could be glacier, it could be river water, or water, simply you can write water, then rains, then other aspect also there. Fine. Now physical can be further divided into granular, can also be divided into thermal, frost, soil, and mass wasting. Chemical can be further divided into dissolution, solution, then you have carbonation, hydration, oxidation, and reduction. So these are okay what? These are different type of physical weathering, these are different type of chemical weathering. Granular, thermal, frost, salt and mass wasting, these are different type of physical weathering. Chemical weathering, dissolution, solution, carbonation, hydration, oxidation, reduction, these are different type of chemical weathering. Or you can have biological weathering.
So what is the last one?
Reduction, oxidation,
Mass.
mass wasting, WASTING, mass wasting. Fine. Now recall our discussion. We discussed exogenic forces are acting above the surface of Earth. So endogenic are happening below the surface of Earth, exogenic on the above the surface of Earth. So what is the reason behind exogenic forces? What is the reason behind exogenic forces? As we discussed, it is going to be what? Sunseed. We discussed whatever processes taking place below the interior of Earth is happening due to what? Earth's heat, that is radioactivity. Whatever happening above the surface of Earth is happening due to what? Sun's heat. So major source of exogenic forces is what? Sun's heat. Major force of exogenic forces is sun's heat. And we discussed exogenic are also referred as what? They are also referred as a levelers. Why they are referred as a levelers?
Leveling.
Because they are eroding, they are destroying things, okay, that's why they are called as a levelers. Clear? Endogenic are creating mountain, this is eroding the mountain, so reducing the height, so that's why they referred as a levelers. So this part we have discussed. Now, the term we use is called as a denudation. There is a term called denudation, which is a common term used for both weathering and erosion. It is a common term used for both weathering and erosion, which is referred as a denudation. So what is a denudation? Denudation is a common term which is being used for both weathering as well as erosion. Fine. Denudation means to strip off or to uncover. So when you are stripping off, removing something, chipping off, this is called as what? This is called as a denudation. So the common term for weathering and erosion is what? Denudation. The term denudation means to strip off, chip off, to take material out. That is what we call as a denudation. And that's why the common term for weathering and erosion is a denudation. Okay? Now what difference lies between weathering and erosion? So as we discussed, weathering only involves what?
Breaking down.
Breaking down.
No transportation.
No transportation, yes. It only involves breaking down and no transportation of material. No transportation of material. Now erosion involves both breaking down also and transportation also. Any other difference? Now we say weathering is which type of process? In situ process. While erosion is which type of process? Called as a ex situ process. In situ means happening at that place, that site itself, that is called as a in situ. Ex situ means happening at a different places, because here eroded material are transported to different location. So that's why erosion is which type of process? Ex situ process. Eroded material are transported to different location, while weathering is which type of process? In situ process. Eroded materials are there at the location itself. They are there at the location itself. So that's why weathering is an in situ, erosion is an ex situ process. Clear? So this is primarily the difference between weathering and erosion. Yeah. Now different type of weatherings are there. One is called as a physical weathering. Physical weathering means weathering that is caused due to physical process. The weathering that is caused due to physical changes or physical process is called as what? Physical weathering. So what type of weathering, what type of things you are finding over here? Yes. So variation in temperature, variation in pressure, humidity, okay, all those particular things. So when you are seeing the variation in temperature, pressure, humidity causing the breakdown in what? Breakdown in rocks, then it is going to be called as which type of weathering? Physical weathering. So what is physical weathering? Physical weathering is occurring due to changes in what? Changes in physical parameter, which are temperature, pressure, humidity. When changes in these parameters causes breakdown of rocks or causes the degradation of rocks, then it is going to be called as what? Physical weathering. And we have divided physical weathering into which how many types? The first one is what? Granular weathering. Granular weathering. So this type of weathering occurs in what? This type of weathering occurs in a rock which are made up of different size. This type of weathering occurs in a rock which are made up of what? Different material, different size of rock. Clear? Let's say it is consisting of what? It is consisting of lighter rocks, lighter material and darker material. Yeah? It is making up of this rocks that we are talking about is made up of which type of material? Lighter material and darker material. That type of weathering is going to be called as a granular weathering. Clear? Now suppose from here sunlight is something that is falling on the rocks. From here sunlight is something that is falling on the rocks. What will happen?
Expansion of
Which type of material absorbs more heat? Darker material. Yes, okay. So we discussed darker material will absorb more heat while the lighter material will absorb less heat. So that's why darker material are going to expand more and lighter material are not going to expand much. Clear? So as a result, darker material will put pressure on lighter material because it is trying to expand, but lighter material is there in the in the path. So it is trying to expand, lighter material is not expanding. This will create what? This will create a friction, and as a result, this rocks will what? This rocks will nothing but this rocks will broken down over a period of time. So this continuous what? Continuous expansion of darker material which will put pressure. So this is okay, darker material, this is lighter material. Now darker material will try to spread, expand, but it is coming, which is coming in the path? Lighter material are coming in the path. As a result, what will happen? You'll see breaking will happen, and this type of weathering is called as which weathering? Granular weathering. This type of weathering is referred as a granular weathering. The second type of weathering is thermal weathering. Again, this also occurs due to the temperature, as when you indicate thermal weathering. So this also occurs due to the variation in temperature itself. Now let's say this rock is there and this is another layers of the rock. This is another layers of the rock. Fine. So this is upper part of the rocks. This is nothing but okay, lower part of the rocks. Clear? Now what will happen is if sunlight is falling, what will happen? The upper part is going to be what? It is going to be more heated. Upper part, it is exposed to sunlight. When it is exposed to sunlight, what will happen? It is going to be more heated. While the lower part is not exposed to sunlight. So lower part is what? Not going to be much heated. Clear? Now, as we discussed, if any material is what? If any material is heated, it is going to expand. So this will expand at the bottom side also, and it is trying to expand at the top side also. It is trying to expand. So when it is trying to expand at the bottom side, what is happening? These lower rocks are something that are affecting their expansion. They are trying to nothing but okay. They are trying to not allow the expansion of whom? Not allow the expansion of upper rocks. As a result, the upper rocks, lower rocks, there will be what? There will be constant frictions, constant other thing that is going to be generated, which led to breaking down of rocks, and this type of weathering is referred as weathering, thermal weathering. Clear? This type of weathering is referred as a thermal weathering. Clear? So granular weathering occurs when rocks are made up of different materials. Generally you see sedimentary rocks, metamorphic rock, they are made up of what? Different materials, because their elements are being brought by different agents, like rivers are bringing some sediments, winds are bringing some sediments. Okay, so they are made up of different material. So when they are exposed to sunlight, granular weathering are going to occur. Thermal weathering, you see entire rocks is trying to expand upper layer, but it is not able to expand because of nothing but okay, the lower part, and this leads to breaking down of what? This leads to breaking down of rocks, and this type of weathering is called as what? Thermal weathering. Fine. The third type of weathering that you are finding over here is frost, salt and mass wasting. The third type of weathering that you have is a frost, salt and mass wasting. Now frost weathering, so one more thing, where thermal weathering are going to be more common? Temperate region. Anyone else? Where the thermal weathering are going to be more common?
Torrid region.
In torrid region, yes, okay. In equatorial region, in torrid region, you will see thermal weathering are more common, because this part of the region receives what? This part of the region receives maximum sunlight. As you go towards pole, what will happen? Sunlight decreases. So that's why thermal weathering are more common in this region, between Tropic of Cancer to Tropic of Capricorn. You will see more thermal weathering are more common. Fine. Next is a frost weathering. These are more common generally where? In the highland region, like mountainous region, etc., or wherever colder atmosphere is there. Colder and warm or alternate atmosphere is there. There you will see which type of weathering? Frost weathering. So alternate colder and warmer atmosphere, or at the highland or mountainous region, you are going to see which type of weathering? Frost weathering. Now let's say this is okay, a type of mountain, and there is a hole that is created in this mountain. Yeah, there is a crack that is being created in this mountain. Now what will happen to this crack? Let's say this crack is filled with nothing but okay, what? This crack is filled with water. Rainfall happened, this crack is now filled with what? Filled with water. Now during the daytime, this is going to be in water form, and during the night time what will happen? It will change into which form? Ice form, because temperature becomes colder, so water will change into what? Ice form. Now this continuous changes of water into ice and ice into water, because you know that when water is changing into ice, what is happening? When water is changing into ice, what is happening? Volume will contract. When ice will change into water, what will happen? Volume will expand. So as a result, when expansion will happen, let's say when expansion is happening, it is going to put pressure on whom? It is going to put pressure on the side of what? Side of the rocks. This is going to put pressure on side of the rocks. When contraction is happening, it is not going to put pressure on the side of the rocks. Clear? So over a period of time, because of this continuous pressure, continuous not putting a pressure, expansion, contraction, will lead to widening of this hole. So this hole will get widened further. This hole will get widened further because of continuous expansion, contraction, and this type of weathering is referred as which weathering? Frost weathering. Yeah, this type of weathering is referred as a frost weathering. Fine. So frost weathering occurs why? Because the water constantly changes into ice, ice changes into water. This put pressure on the underlying wall of the rocks, and when it put pressure on the underlying wall of the rocks, the hole get expanded, and this type of weathering is referred as which weathering? Frost weathering. Fine. The next type of weathering is referred as what? Salt weathering. The salt weathering are more common in desert region. This type of weathering is more common in which region? This type of weathering is more common in desert region. Fine. So in desert region you see what? You see more evaporation. In desert region what is happening? More evaporation and less rainfall. What happens in desert region? You will see more evaporation is happening and less rainfall is happening. Because of this what will happen? Because of this what will happen?
Salt formation.
Whenever any water will evaporate, what it will leave behind? It is going to leave behind salt. Okay? When water will evaporate, what it will leave behind? Salt. Fine. Sometimes, okay, like when you are sweating heavily, sometimes you see some white color being appearing on your, okay, on your shirts, on your, okay, on your, okay, clothes. Why this white color appears? Because sweat evaporate, what is left behind is a salt. Salt is causing this white thing on your clothes, okay, that is okay there. Clear? So this also happens in a desert region. Desert region, what is happening? Rainfall is not much happening and water is constantly evaporating. As a result, what will happen? Lot of salt is going to be formed. Now let's say this is a region where crack is okay there. Now let's say rainfall had happened. Here what is happening? Water is being deposited. Rainfall has happened, water is being deposited. Now because it is a desert region, constantly water deposit, rainfall will not happen. When constantly rainfall will not happen, this water will get evaporated. This water will get evaporated, and when it get evaporated, what will leave behind? It will leave behind salt. It will leave behind salt in this particular hole. So water is evaporated, what is left behind? Salt in this. Over a period of time, this salt will become more crystallized. This salt will become more crystallized. This will become more bigger in nature. Crystallization of salt will happen and this will become more bigger in nature. When it will become bigger in nature, it will put pressure on the walls of the hole, and as a result you will see the hole will become more bigger and bigger. The hole will become more bigger and bigger. So this will become more bigger and bigger due to the pressure of, okay, the salt crystal, and thus such type of weathering are referred as what? Such type of weathering are referred as a salt weathering. Fine. So what is happening? Rainfall happens, water get deposited over here. Since it is a desert region, evaporation is not happening. Water is evaporated, what is left behind? Salt are left behind. When salt crystallizes, it becomes more bigger in nature. When it becomes more bigger in nature, it will put pressure on what? Put pressure on the holes, and as a result, this will further get what? Further get expanded. Such type of weathering are referred as what? Such type of weathering are referred as a salt weathering. Fine. So any doubt in frost and salt? So where do we see thermal weathering? We discuss more in torrid region, where you're going to see frost weathering generally in mountain, where water can convert into ice or ice can convert into water. Lower temperature, warmer temperature is there. Where salt weathering generally in less rainfall region, desert region, there you're going to see more of salt weathering being dominated. And the last type of weathering is referred as a mass wasting. Last type of weathering is referred as a mass wasting. Now let's say any rock is like this on the slope of mountain. What will happen? What will happen? It will be constantly attracted due to what? Gravity. It will constantly attracted due to the gravity. Let's say it has it has a more weight. It has a more weight and it is trying to resist resist the gravity. But over a period of time, some weathering has happened in this rock, and when the weathering has happened, what will happen? This has become more loose. When it has become more loose, it will not be able to resist what? Resist the gravity, and this will start to fall down under the influence of gravity. This starts to fall down under the influence of gravity. Then such type of things are called as what? Such type of things are called as a mass wasting. So mass wasting causes landslide. Landslide occurs. Sometimes you see huge land, okay, comes down. This occurs due to what? This occurs due to mass wasting phenomenon. Fine. Fine. So these are different type of what? These are different type of weathering. So what is weathering? When decomposition and breaking down of rock will occur, that is going to be called as what? That is going to be called as a weathering. And in weathering, no transportation of what? Material is going to happen. Weathering is which type of process? In situ process. Okay, so weathering is going to be which type of process? Weathering is going to be in situ process. It is going to be an in situ process. Remember, different kind of weatherings are there: physical weathering, chemical weathering, and biological weathering. So how many type of physical weathering? Granular, thermal, frost, salt, and mass wasting. So the first we have discussed is what is physical weathering. What is physical weathering? The one which occurs due to the changes in temperature, pressure, or humidity. That is physical parameter. If it is changing, then it can lead to which type of weathering? Granular weathering. In which type of rock granular weathering will occur? If the rocks are composed of what? Different material, lighter material or darker materials. You know that darker material absorbs what? More heat. So as a result, it will expand more. Lighter material absorbs less heat. So as a result, it will not expand much. So when darker material trying to expand, what is coming in the way? Lighter material is coming in the way. Friction is going to be generated. This led to breaking down of what? Rocks, and such type of weathering is called as a granular weathering. Second type of weathering is what? Thermal weathering. When sunlight falls onto the upper rocks, what will happen? It will get heated and try to expand, while the lower rock will not get heated. So as a result, what will happen? Friction is generated between upper and lower rocks, and this led to breaking down of rock, and this type of weathering is referred as thermal weathering. The third type of weathering? Frost weathering. Where frost weathering will occur? In the highland region. We discussed here the water will convert into ice. Ice will convert into what? Water. It will put pressure on whom? It will put pressure on underlying rock. As a result, hole will what? Hole will further get elaborated, and this type of weathering is referred as a frost weathering. The fourth is salt, where it is going to dominate desert. So as we discussed, the water rainfall happen, water get deposited in these cracks. When water get evaporated, crystals, salt crystals are going to be formed. This salt crystal combines to form bigger crystal, and it will start putting pressure on the holes, and as a result, this holes will break down and become much bigger. This hole will break down and become much bigger. This type of weathering is referred as salt weathering. The last is what? Mass wasting. So when the rock starts to fall under the influence of gravity, that is called as a mass wasting, and we discussed mass wasting result in what? Landslide. Clear? So these are types of what? These are types of physical weathering. Second is what? Chemical weathering. Chemical weathering. And we have divided chemical weathering into how many parts? Solution, dissolution, carbonation, yes, hydration, hydration, oxidation, and reduction. So those are the types. So chemical weathering, why it occurs? This type of weathering is occurring due to the chemical changes in rocks. When chemical changes in rocks are happening, rocks are getting decomposed, broken down, and such type of weathering are referred as what? Such type of weathering are referred as a chemical weathering. So why the chemical changes are occurring? Chemical changes are occurring due to these processes. So when chemical changes in rock occurs, rock get decomposed or broken down, then such type of weathering are referred as a chemical weathering. And what are the chemical changes? Chemical changes are these ones. Now the first term that you have to understand is oxidation and reduction. What is the difference? Anyone?
Oxidation is adding of oxygen and reduction is reducing
Yes.
hydrogen molecule.
reducing hydrogen molecule,
Atom.
atom. No, either you define, there is a three definition. The older definition was what? Older definition was addition of oxygen is called as a oxidation and removal of oxygen is called as what? Reduction. When oxygen is being removed, then it is called as what? Reduction. This was older definition. Then came removal of hydrogen is called as what? Oxidation. Addition of hydrogen is going to be called as what? Reduction. Then it is a second definition. So this is okay, addition of hydrogen or removal of hydrogen. The third definition that has come, which is currently being used, these definitions are also being used, but these are not comprehensive definition. The third definition that has come is loss of electron is called as what? Oxidation. Gain of electron is called as what? Reduction. Gain of electron is called as what? Reduction. Loss of electron is called as what? Oxidation. Gain of electron is called as a reduction. So these are the three different definitions that you are finding with regard to oxidation and reduction. So older definition was that anything which have oxygen, anything in which you see addition of oxygen is going to be called as a oxidation, removal is going to be called as a reduction. Here you will see removal of hydrogen, oxidation, addition of hydrogen, reduction, and here you will find what? Here you will find loss of electron and gain of electron, because there are certain substances which are going under oxidation and reduction, but there is no addition of oxygen and hydrogen there happening. That's why modern definition has come. So this is okay, what modern definition with regard to, like you have this CuSO4 plus Zn. This is okay, what? This is reacting to form what? ZnSO4 plus Cu. So here what is happening? You see this Zn is reduction is happening. It is forming Zn2 plus and SO4 2 minus. They are combining to form what? They are combining to form ZnSO4. So here Zn is losing 2 electron. He is losing 2 electron. That's why positive charge. As you know that loss of electron will lead to what? Positive charge. We have discussed atom is consisting of what? Nucleus. And atom is electrons are revolving around nucleus. So we have same number of what? Same number of nothing but okay, electron and proton. If in an atom we have same number of electron and proton. That's why we discuss atom is what? Neutral. No charge is there on the atom. It is neutral. If it loses electron, then what will happen?
Gain positive charge.
Then you see positive charge is more. And if positive charge is more, then okay, what will happen? You'll see it will acquire what? Zn2 plus. If negative charge is more, then it will acquire what? It will acquire more electron. If it acquire more electron, then what will happen? Negative charges will become more. Clear? So in this process, you see neither addition of oxygen is happening nor removal of oxygen is happening. So as a result, okay, this type of okay things are explained through what? This method, which is a loss of electron and gain of electron. So here Cu is gaining the electron to become what? Cu2 plus is gaining to become Cu. Zn is losing electron to become what? Zn2 plus, okay, that is okay there. So this is what we call as a definition for oxidation and reduction. Clear? So if any material is going under the loss of electron, then it is going to be called as what? Oxidation. If it is going under the gain of electron, then it is going to be called as a reduction. Clear? So if let's say if any material is there, let's say NaCl, salt is there, what will happen? You have Na positive and Cl minus. It is going under loss of electron, it is going under what? Gain of electron. So you have okay what? You have formation of salt, okay, that is okay there. So this process is what? This process is referred as oxidation and reduction process. So when any material goes oxidation and reduction, chemical changes will occur. These chemical changes may lead to what? May lead to decomposition of rocks. Clear? Any doubt regarding this particular thing? Next, another term that you have is a carbonation. Carbonation means addition of carbonate ion. Addition of carbonate ion, bicarbonate ions, or even carbonic acid. So when you have addition of all these, carbonate, bicarbonate or carbonic acid, that is called as a carbonation process. Clear? What is carbonate oil means? Carbonate oil means CO3 2 minus. This is called as a carbonate oil. So when you have addition of carbonate, bicarbonate or carbonic acid, that is called as what? That is called as carbonation process. Like we have CaCO3, no? Calcium carbonate. So calcium carbonate is what? CaCO3. Addition of which ion is happening? Carbonate ion is something that is okay happening. CaCO3 is what? Limestone. So calcium carbonate is what? Your limestone. Clear? Any doubt regarding this particular thing? Like you have sodium bicarbonate, NaHCO3. So when you have addition of this HCO3 minus ion, then it is called as what? It is called as a bicarbonate. Clear? What is carbonate? Carbonate is addition of which ion? CO3 2 minus, like you see in calcium carbonate. Clear? What is bicarbonate? Addition of HCO3 minus, which is okay, like sodium bicarbonate.
Sir, all these are chemicals.
All these are chemicals. All these are chemicals. Your mineral is what? Chemicals only, no? Hydrogen, oxygen, you see iron. So these materials are present. When they undergo chemical changes, then it is going to call as chemical. And the third is a carbonic acid. What is carbonic acid? Like addition of COH. If this is adding in any compound, then it is called as what? It is going to be called as a carbonic acid. Like CH3COOH. It is referred as acetic acid. Vinegar. Okay, vinegar is okay, nothing but your what? Acetic acid. So what you see is when addition of this ions, this compound is there, it is called as a carbonation. So carbonation is a process when there is a addition of carbonate ion, addition of bicarbonate ion, or addition of nothing but okay, carbonic acid. That process is referred as which process? Carbonation process. Next is what? Hydration. What is hydration?
Addition of H2.
Addition of H or OH minus. So you have H plus ion addition or OH minus addition. That process is going to be referred as what? Hydration. Clear?
Addition of hydrogen.
Yes, addition of H plus or OH minus. H plus means hydrogen, like hydrogen has okay one, you have okay what? You have hydrogen has a first atomic number, no? So we discussed how many electron hydrogen will have? One electron. How many proton hydrogen will have? One proton. Clear? If hydrogen loses this electron, then what will happen? It will be only having what? Proton, and this proton is referred as what? H plus. Clear? So like we discussed HCl, no? Hydrochloric acid. So hydrochloric acid, how it is formed? H plus and Cl minus. So hydrogen loses electron, chlorine gains an electron. So this forms your what? This forms your hydrochloric acids. Clear? Electrovalent bonding. We have discussed two bonding, electrovalent and covalent bonding. Clear? So when there is an addition of H plus ion and when there is an addition of OH minus ion, that process is referred as which process? Hydration. So clear? What is oxidation? What is oxidation? Loss of electron, reduction, gain of electron, hydration, addition of H plus ion or OH minus ion, carbonation, addition of carbonate, bicarbonate or carbonic acid. Next is dissolution. What is dissolution? So dissolution means okay, you are talking about two things. So you have studied about something called solute and solvent. What is solute and what is solvent? Like let's say sugar. So sugar becomes your solute, solvent becomes your water. When you are dissolving sugar in solvent, it is going to be called as what? It is going to be called as a solution. When it is going to be called as a solution? Solution is an homogeneous mixture. Solution is called as a homogeneous mixture. What is homogeneous means?
Same throughout.
Yes. When sugar, when we are talking about solute and solvent, we are talking about this. So sugar get dissolved in water. Sugar get dissolved in water means what? Sugar is uniformly present. It's uniformly distributed in the water. Then such type of things are going to be called as which mixture? Homogeneous mixture. If sugar get okay dissolved, means it is uniformly distributed inside the water, then it is going to be called as a which type of okay mixture? Homogeneous mixture. Let's say you put sand in water. Sand in water, what will happen to sand? Sand will settle down. It is not uniformly distributed. Okay, it is present only at the bottom. So it is not uniformly distributed in what? Distributed in the solution. So when solution, we call it as a something as a solution. When things are uniformly distributed throughout the area. Clear? So when sugar is spread uniformly throughout, it becomes a which type of mixture? Homogeneous mixture. And if it is not distributed, then it is going to be called as heterogeneous mixture. It is going to be called as a heterogeneous mixture. So solution is what? Solution is a uniform homogeneous mixture. It is called as a uniform homogeneous mixture when solute is dissolved in solvent. Clear? So when rainwater is happening, what will happen? When rain is happening, what will happen? When rain is happening, what is going to happen? Let's say this is a rock. This rock contains what? This rock contains mineral. When rain falls, what happens? This mineral may get dissolved in what? May get dissolved in water. When this mineral get dissolved in water, what will happen? It will go down with the water. When water will go down, mineral will also go down. What will happen to the rock then? It becomes loose because mineral is gone. When it becomes loose, what will happen? It becomes easier to decompose or break down. Fine. So there are many many chemicals which get dissolved in water. There are many chemicals which do not get dissolved in water. Clear? So some substances do get dissolved in acid, but they do not get dissolved in water. Fine. So that is the reason why you see sometimes acid rain happens. Last class we discussed MC Mehta case. What was MC Mehta case? Taj Mahal case. Okay, so we discussed industries were moved out from what? From Taj Mahal area. Why? Because we discussed calcium carbonate is this marble which is what there in the Taj Mahal is being impacted due to what? Is being impacted due to acid rain, because material get dissolved in what? Material also get dissolved in acid. So either material can get dissolved in water or material can also get dissolved in acid also. Fine. So this process, and the last is what? Dissolution. Dissolution is what? Here also solute and solvent are going to be there, but this is not going to be which type of mixture? Homogeneous mixture. Solution is what? Uniform homogeneous mixture. Dissolution will not be having a uniform mixture. Clear? Let's say once sugar get dissolved in water, can you separate sugar in water? No, because why? Sugar is uniformly distributed. Yeah, but when you when you put the sand in water, what will happen? You can separate. Physical separation can happen. Yeah, so that is what homogeneous mixture and heterogeneous mixture is called. So when rock get decomposed or broken down due to what? Due to the chemical changes in rock, then such type of weathering is referred as chemical weathering, and chemical weathering is due to solution, dissolution, carbonation, hydration, oxidation and reduction. Fine. The third type of weathering we have is of biological weathering. Biological weathering. Now, when breaking down or decomposition of rock occurs due to what? Biological element. When breaking down or decomposition of rock occurs due to biological element, what are biological element? It could be very basic like mosses and lichens, could be earthworm, any burrowing animals, even humans or bigger animals. When the breaking down of rock happens due to biological aging, then such type of weathering is referred as which type of weathering? Biological weathering. Fine. What is mosses and lichens? Now in environment classes, you will study about the succession process. Succession process. Succession is what? How life has evolved in a region. That is called as a succession process. So you will find when a volcanic island is formed, when volcanic island will form, there will be what? There will be no life, because this island is formed. There is no life existing. How the life will start over here? It is a rock. No soil is there, no other thing are there. How life will start? It will start with this one. This is the very basics. Mosses and lichens starts the succession process. So when mosses and lichens, they have the capability to develop on a bare rocks. What is lichens? They can develop on a bare rocks. What is a lichen? It is a symbiotic relationship. symbiotic relationship between algae and fungi. That is called as lichens. Symbiotic relationship. What type of relationship is called as a symbiotic?
Dependent on each other.
When both are benefiting each other. When both are benefiting each other, then such type of relationship is called as what? Symbiotic relationship. So algae provide food to whom? Fungi. Fungi provide protection to whom? Algae. So what will happen is, okay, both are helping each other, then such type of relationship is going to be called as what? Symbiotic relationship. Now, because of this, you will see on the rocks, organic matter starts to develop. This organic matter is very important for the development of soil. This organic matter is very important for development of soil. When soil will form, then only what will happen? You'll see plants are going to develop, producers are going to develop. When plants are developed, then what will happen? You'll see animals and others, food chain. So you know that who is a producer? Plants are producer. So food chain will only start when plant develop. Plant will develop when soil will develop. Soil will develop when organic matter develop. Organic matter develop when there is, okay, what? Development of mosses and lichens. So mosses and lichens starts to break down the bare rocks and start to deposit which type of material? Organic matter. This leads to what? This leads to decomposition of what we call as the rocks. This leads to decomposition of what we call as the rocks. Yeah? Earthworm. You know that earthworm, what it does? It goes beneath the soil. It goes beneath the soil and bring the soil material up, take the soil material down. It is starting mixing of soils, okay, that is okay there. So this also helps in what? This also helps in decomposition of rocks. What is burrowing animals? Yes, that goes down. So that goes down. Like snakes can be, some snakes are burrowing animals. You see rats are there. Yes, so they goes underground and they try to decompose, okay, the rocks. Those type of animals are called as the burrowing animals. Now humans, let's say you are living in a hilly region and you are constantly moving, okay, what? Constantly moving on a rock. What will happen? If you are living in a hilly region, constantly you are moving on a rock. What will happen? Over a period of time, because of friction, uncovering will occur and it will break down over a period of time. You also create infrastructure. No? You cut down, okay, hilly region to create a road. Yeah? Mountain, on mountains, you visit Ooty, you visit, okay, what other regions. So what is there? You have created nothing but the roads over there, no? Infrastructure you have created. So you have created, how you have created those? By breaking down the rocks. So humans can also go for nothing but weathering. This type of weathering are referred as what? Biological weathering. Clear? So there are three different types of weathering: physical weathering, chemical weathering, and biological weathering. Physical weathering due to changes in physical parameter like temperature, pressure, and humidity. Chemical weathering is due to what? Changes in chemical composition. And third is biological weathering occur due to biological elements. Clear? And what are the types of physical weathering we have discussed? Granular weathering, thermal weathering, frost weathering, salt weathering, mass wasting. Yes. And what are the types of chemical weathering? Oxidation, reduction, carbonation, hydration, solution, and dissolution. And what is the type? What is the biological weathering? Many agents are there which can cause nothing but biological weathering. The next process, exogenic process that we have is what? Erosion. So as we discussed, what is erosion? Here what will happen? Not only breaking down will happen, but also, yes, transportation of material will happen. Transportation of material will happen. When transportation happens, then what will happen? We'll also see somewhere what will happen. Deposition will also happen. So breaking down of material, transportation of material, and somewhere deposition of material will also happen. Here, what are the agents which is causing the breaking down or causing the transportation? Water, wind, glaciers, yes. So these are okay, what we call as an agent of erosion. These are referred as what? Agent of erosion. Now, one type of, okay, when we were discussing about endogenic and exogenic, we have written water can cause different type of, okay, what, erosion, which were called as a sheet erosion, gully erosion, we have written rill erosion
and splash.
and splash erosion. Yes. So those are the types we have written that can be caused due to water. So sheet erosion, gully erosion, then you have rill erosion, and then you also have splash erosion. Fine. Now what this splash erosion is all about? Let's say there's a soil particle. This is how the soil particle or something that are present. And let's say this is a rain droplet. It falls down. This is a rain droplet which is falling down. What will happen?
So sediment will be splashed.
The sediment will be nothing but a splash. So when rain water will fall, the material at the bottom will nothing but move away, and this type of erosion is called as what? This type of erosion is called as a splash erosion. This type of erosion is referred as a splash erosion. So because this rain water has certain weight, when it falls down, it is going to nothing but what? Defragment the soil particles. Soil particles will move away, and this type of erosion is going to be called as what? Splash erosion. Clear? Now let's say if this splash erosion continue to occur, what will happen? If this was okay, what? This is how the things were there. This is how soil particles were there. And because of splash erosion is constantly occurring due to fall of water molecules, what will happen? Empty space is going to create it. Like this, okay, you see soil particles will be, so you see like this. This empty space is going to create it, and material from here will move away. So this empty space are going to be created. This can create which type of erosion? Rill erosion. This can create which erosion? Rill erosion. When rill becomes widened, it becomes which type of erosion? Gully erosion. It becomes gully erosion. And let's say when rainwater falls like this, and there is a slope like this. If rainwater falls like this, and there is a slope, mountain slope, what will happen? Now rainwater is coming down from here to here. So rainwater is falling over here, and from here this water is coming down at the bottom, at the other thing. So they will take what? They will take entire sheet of the soil from here to here, and this type of erosion is going to be called as what? This type of erosion is going to be called as a sheet erosion. When you move entire upper layer of the soil, then it is going to be called as which type of erosion? Sheet erosion. So what is splash erosion? When rainwater is falling, what will happen? It will fall, it has a certain weight, because of this soil sediments will get splashed. That type of erosion is called as what? Splash erosion. Because of this splashing, what will happen? A space is going to be created. This space is going to be called as a rill erosion. When rill get widened, what will happen? Gully erosion. And when entire upper layer of water is going to be removed, then it is going to be called as a sheet erosion. So these all can be caused due to what? These all can be caused due to water. Clear? So that's why when you see the figure, now you can see this particular thing. So what is happening over here? Because of the rainwater, what is happening? The soil sediments are moving away from this region. So as a result, what is happening over here? cracks are being developed. When this crack get widened, what you are seeing? Rill erosion. When this becomes further widened, what you are going to see? Gully erosion. And finally, when you see entire layers of soils are being removed, it is going to be called as which type of erosion? Sheet erosion. So when rainwater falls, the sediments are going to splash. As a result, this crack is going to develop. When this crack becomes widened, you will see rill erosion. When it becomes further widened, you are going to see which type of erosion? Gully erosion. And when entire layer of sheets of soil is being removed, it is going to be called as a sheet erosion. Fine. So these type of erosion can occur due to water. These type of erosion can occur due to water. Clear? Now there are different agents as we discussed. Soil, water is agent, glacier is agent. So when water is causing an erosion, as we discussed, erosion is also happening and deposition is also happening. So water is taking sediments from one place and depositing at other place. So that's why different landforms are going to form. Clear? So whenever rivers forms a landform, it is called as which type of landform? Fluvial landforms. Clear? So when river erodes and take material from one end to another end, it forms a certain landform which is called as which type of landform? Fluvial landform. For example, you see waterfall. Waterfall is which type of landform? Erosional landform. Water has eroded the rocks. As a result, it is falling from one height to another height. So this waterfall is which type of? It is going to fluvial landform. You see deltas. River forming what? Deltas. So this deltas is which type of example? Fluvial landforms. So tomorrow we'll start with which concept? Tomorrow we'll start with concept of fluvial landforms. Okay, so we'll start with concept of fluvial landforms. Then we have whatever things that are going to be formed with the glacier are going to be called as what? Glacial landform. Whatever thing that are going to be formed due to the wind is going to be called as a wind landform or aeolian landforms. It is also referred as a aeolian landforms. Okay, so we have to now discuss these agents of erosion and what are the landforms that are being formed due to these agents of erosion. Fine? Yeah. So what we try to cover today is what? We try to cover today is positive and negative of volcanic eruption. Then we discuss volcanic landforms, that is extrusive landform and intrusive landform, hotspot volcanism and concept of mantle plume, that we have covered. Then we covered what? Exogenic forces. Then we have covered the concept of denudation. What is denudation?
Weathering and erosion.
Combined weathering and erosion. Then we discuss weathering, different type of weathering, and erosion, concept of erosion. Fine? Any doubt regarding this one? Thank you.
Thank you, sir.
So try to go through the notes, okay, which have been provided, and also this week when we are conducting tests, we will also cover previous week also and this week also, fine? So that you have constant revision of previous week also. Thank you.
Sir.
Please, could you be able to